Welcome again to Chibuzor Mathphysics. I will be taking you through Doppler effect and sound calculation. In physics, especially most times you see this in waves and optics. So what exactly is Doppler effect? Doppler effect most of the time refers to the change in wave frequency during the relative motion between a wave source and its observer. So there must be a source and there must be the one observing. For instance, we can say when a sound object moves towards you, the frequency of the sound wave increases. And when it moves away from you, it also decreases. So it depends. We will be doing some calculation, and what we refer to as Doppler effect is just this different change in frequency, and that is exactly what we're talking about. So let me take you through it immediately. Now we have a question here. Two out of phase loudspeaker A and B. If you look at the diagram, A to B, they are out of phase. And now A and B faces each other and are separated by a distance of 2 meters. The speaker emits sound waves at a frequency of 725 Hz. The speed of sound is given as 343 meters per second. So the question is that what is the wavelength of the sound wave? You have to calculate the wavelength of the sound wave. Remember that these two are out of phase, but they face each other and they are all separated. The distance between this point A to point B is 2 meters. So they emit sound wave at the frequency of 725 Hz. So you have to also locate all the point on the x-axis as indicated. This point, the line here is labeled as x-axis. So you have to locate all the point on the x-axis between the two speakers as measured from speaker A up to B. Constructive interference occurs because in this we have two types of interference. We have what we call the constructive interference and we have also the destructive interference. For more about interference, you need to watch my previous video where I take time to explain what is constructive and destructive interference. So what we are going to do here, we are given basically when you are doing physics, you need to learn how to interpret the equation. You know what you are given and then you know which formula to use and what you are looking for. So if you look at the equation, here we are given the speed of sound to be 343. So V represents the speed of sound and it is given in the equation as 343 meters per second. So now we have the frequency of sound which is 725 Hz. What are we looking for? We are going to use this formula V is equals to F lambda because we have the speed of sound as V. We also have the frequency, but we are looking for the wavelength. Remember, in the first question, you are asked what is the wavelength of the sound wave. So we have to calculate the wavelength of the sound wave. So we are going to apply this formula. But since we are looking for lambda, we make lambda the subject so that it will become an inverse relationship. So that lambda will be V divided by F, which is the frequency. And if you put our the values we were given, you will simply have 343 meters per second, which is the speed of sound, divided by 725 Hz, which is the frequency, and this will give you 0.47 meters. And therefore, our wavelength of sound wave is 0.473 meters. And this is the first solution. So now let us go back to our question. We are also to locate all the point on the x-axis between the two speakers as measured from speaker A and B. You have to be very careful here because remember these two are out of phase. And if they are not out of phase, there are also a different formulas to use. But since they are out of phase, you have to be careful the way we go about the solutions. So let us see what we are supposed to do. We know that for constructive interference, because the question says in B that where constructive interference occurs, so we are going to focus more on where there is constructive interference. So where constructive interference occurs, path difference between two will be given by the wave to be n multiplied by wavelength of the wave divided by 2. N is equals to 0 plus or minus 2 plus or minus 4 plus or minus 6 and others. So they are all even numbers because we are talking about constructive interference. So we are going to be using these even numbers. So these little change will be given by the number multiplied by lambda divided by 2. Remember here it is the wavelength of the wave. So it is lambda divided by 2 and we already calculated our lambda. So let's consider the constructive interference at x m from A. Remember we have x. Look at this small illustration that I have put here. Between this A to point C is our x, and between this point C to B is 2 minus x, this point, because we are looking at where the constructive interference occurs. So the distance from B is going to be 2 minus x, and you will multiply it by m. So the path difference will be given by x minus 2 minus x because we have x here. This we are concentrating on this x-axis. So it will be x minus 2 minus x, which will give us 2 into x minus 1. So now, if we continue from where we stopped from the previous slide, we know that we are looking for n lambda divided by 2. So 2 into this x minus 1 will be equals to n lambda divided by 2. So that our x minus 1 will be given by n lambda divided by 4 because 2 multiplied by these 2 will just give us 4. So that we will have 1 plus n lambda divided by 4 because we want to make x the subject. Of course, when this negative 1 crosses over, it becomes positive. So we will have 1 plus n multiplied by 0.473. This is what we got in our first equation. Remember when we calculated the lambda, we calculated lambda here and we got 0.473. So we just need to plug it into this equation so that we plug it here and we have 1.2365 meters as our n when it is 2. So we are going to calculate using even numbers. So when the number of the interference is 2, it is 1.23 6 and 5 meters. When it is 4, you simply need to plug into 4 here, multiply it by 0.473, which is our lambda, divide by 4, and you have this 1.473 meters. When it is 6, this is what we have. Plug it 6, multiply by lambda, divide by 4. When it is 8, 1 plus 8 multiplied by 0.47 divided by 4. And when it is 10, because we are using even numbers, so n 10 is not between a times b, so it is not acceptable, so we don't use this. So we can, that is why I have written that 2.1825 is greater than 2, so we have to use up to 2 and 8. So this is how we calculate the sound using this Doppler effect. Now we continue. We have when it is negative 2, that is from the negative side. When it is negative 4, when it is -6, and when it is -8. Simply plug into 1, -2 multiplied by our answer, what we got in A as our lambda divided by 4. This is what you get. When it is -4, do the same. When it is -6, do the same thing, and so. So constructive interference happen at the distance from a speaker is 0.054 meters, 0.02905 meters, 0.527 meters, 0.7635 meters, 1 meter, 1.2365 meters, 1.473 meters, 1.7095 meters, and then 1.946 meters. So these are where constructive interference occur using our x-axis. I have used this to demonstrate what we call constructive interference. Look at this diagram. You can now represent your answer in a diagram. This is showing us the distance between the trough and here is the constructive interference. This side will be the destructive interference. I have said for more about destructive and constructive interference, refer to the previous video where I have substantially explained what is constructive and what is destructive interference. And this is how we calculate Doppler effect in line with the moving cars. We try to analyze their frequencies of two out of phase loudspeaker, whether it is A, B, or even if it has A, B, and C, you just follow the same formula and you are good to go. Learn physics while you are smiling. Otherwise, all the best. I remain your humble friend, Galagash. Remember to subscribe to this channel.